Right now, something ancient is tearing itself apart in our solar system, and what scientists found hiding behind it changes everything we thought we knew about visitors from deep space. On October 29, 2025, the interstellar comet 3I Atlas vanished behind the Sun. When it came back out just weeks later, astronomers couldn't believe what they were seeing. This wasn't the same object anymore. Something had changed. Something massive had emerged. And the more they looked, the stranger it got. Because buried in the data from this ancient traveler are signatures that shouldn't exist, compositions that defy our models, and a survival story that breaks every rule we have about how comets are supposed to behave. Let me take you back to July 1st, 2025. That's when astronomers at the Atlas telescope in Chile first spotted it, a faint smudge moving across the sky. Within hours, they knew they had something special. This wasn't just another comet. The trajectory was wrong. It was moving too fast and coming from the wrong direction. After running the calculations over and over, the team realized what they were looking at: an interstellar object, only the third one ever confirmed in human history. Think about that for a second. In all of recorded astronomy, across thousands of years of watching the skies, we've only caught 3 visitors from beyond our solar system. The first was Oumuamua back in 2017, that cigar-shaped mystery that tumbled through our neighborhood and left scientists arguing for years about what it actually was. Then came Borisov in 2019, a more normal-looking comet, but still clearly alien to our system. And now this, 3I Atlas. But this one was different from the start. Because when researchers at the University of Oxford analyzed its path, they discovered something that sent chills down their spines. Based on where it came from and how it's been moving through space, they calculated that 3I Atlas likely originated from the Milky Way's thick disk. That's a population of ancient stars that formed way back in the early days of our galaxy. We're talking about stars that existed before most of the galaxy's modern structure even took shape. And if that's true, if this comet really does come from that ancient stellar neighborhood, then the age becomes almost impossible to wrap your head around. This object could be 7 to 14 billion years old. Let me say that again, 14 billion years. Our entire solar system is only 4.6 billion years old. That means this comet could have been drifting through the galaxy since before our sun even existed, before Earth formed, before anything in our cosmic backyard was even a cloud of gas. This thing is older than our home, and it's been traveling through the void of interstellar space for longer than we can truly comprehend, getting blasted by cosmic radiation, exposed to the harsh nothingness between stars, carrying with it the chemical fingerprints of a stellar system we'll never see. But age wasn't the only weird thing about 3I Atlas, not even close. When the James Webb Space Telescope turned its instruments toward this visitor, the data that came back made absolutely no sense. Every comet we've ever studied in our solar system is dominated by water ice. That's the standard recipe. Water with some carbon dioxide mixed in, maybe some carbon monoxide, and various rocky minerals. But 3I Atlas flipped that script completely. The carbon dioxide to water ratio was 8 to 1. 8 to 1. That's almost unheard of. Typical solar system comets might have a ratio closer to 1 to 10 or even lower. This thing was pumping out CO2 at levels that astronomers had simply never seen before in any comet anywhere. And it gets stranger. They also detected nickel, pure nickel vapor in the coma surrounding the nucleus. Now, nickel isn't impossible in space, lots of objects contain metals, but the way it appeared here was wrong. Normally, when you find nickel in cosmic objects, you find it bonded with iron. That's just how these elements behave in natural settings. Nickel-iron alloys are common in asteroids and meteorites. But here, nickel without iron? That combination is something we usually only see in industrial processes here on Earth. We make nickel alloys in factories by carefully separating elements. Nature doesn't typically do that. Yet here was 3I Atlas casually venting pure nickel vapor into space like it was the most normal thing in the world. The chemical signature of this object pointed to one undeniable conclusion. It formed in a completely different environment than anything in our solar system. A different star system with different conditions, different radiation levels, different planetary dynamics. This comet carried in its bones the story of a place we will never visit, a distant sun that might not even exist anymore. But even with all these bizarre features, nothing could prepare astronomers for what was about to happen when 3I Atlas reached perihelion. That's the point in its orbit where it gets closest to the sun. And for an interstellar visitor coming in at insane speeds, perihelion is a moment of extreme violence. The perihelion mystery. As October approached, 3I Atlas screamed toward the sun at over 68 kilometers per second. For reference, that's about 152,000 miles per hour. At that speed, you could cross the entire United States in less than 20 seconds. And this ancient ball of ice and rock was hurtling toward the most intense heat source in our neighborhood. The problem? For several weeks in late October, 3I Atlas would pass directly behind the sun from Earth's perspective. Astronomers call this solar conjunction. From our viewpoint, the comet would be hidden in the sun's glare. Ground-based telescopes would be completely blind. Even space telescopes would struggle. For those critical weeks when the comet experienced the most intense heating of its entire journey, we couldn't see it. We couldn't watch what was happening. It was like the universe pulled a curtain closed at the most dramatic moment of the story. And that's when the speculation started. Harvard astrophysicist Avi Loeb, a researcher who's never been afraid of controversial ideas, pointed out something interesting. If you wanted to perform a gravitational maneuver to change your trajectory through the solar system with maximum efficiency, you do it at perihelion. It's called an Oberth maneuver. By firing engines or making course corrections at the point of highest velocity near a massive gravitational source, you get way more bang for your buck. If an advanced civilization wanted to send a probe through our solar system and alter its path for a specific destination, perihelion would be the perfect moment to do it. Hidden from view, maximum gravitational assist available. Now, most mainstream astronomers dismiss this as wild speculation. And to be fair, there was zero evidence suggesting 3I Atlas was anything other than a natural comet. But Loeb's point highlighted a genuine mystery. What was actually happening to this object during those hidden weeks? Was it just experiencing normal cometary outgassing? Or was something more dramatic behind that curtain of solar glare? The answer came in early November, when 3I Atlas finally emerged. And what came out was barely recognizable. The massive emergence. On November 8th and 9th, telescopes around the world locked onto 3I Atlas as it cleared the sun's glare. And the images that came back stopped astronomers mid-sentence. This wasn't the relatively simple cometary structure they'd been tracking before perihelion. This was something completely new. The comet had developed at least 7 distinct jets erupting from different points on its nucleus. These weren't gentle puffs of gas. These were violent, directed streams of material blasting into space with incredible force. But here's what really stunned everyone. The comet now had dual anti-tail jets pointing directly toward the sun. Let me explain why that's so bizarre. Normal comet tails point away from the sun. That's because solar wind, this constant stream of charged particles flowing out from the sun, pushes dust and gas in the anti-solar direction. That's Comet Science 101. Every kid who's ever seen a picture of a comet knows the tail points away from the sun. But anti-tails? Those are rare. They're usually optical illusions caused by viewing geometry, where we're looking at a comet from an angle that makes old dust along its orbital path appear to point sunward. They're typically faint and subtle. 3I Atlas had massive, bright, organized anti-tail structures aimed like searchlights back toward the sun. And there were 2 of them, symmetrical, powerful, completely unexplainable by conventional cometary models. British astronomers Michael Buchner and Frank Niebling measured these structures and published numbers that seemed almost impossible. The anti-tail jets extended approximately 950,000 kilometers toward the sun. To put that in perspective, that's roughly 6.3 times the distance from Earth to the sun. The primary tail, stretching in the opposite direction, measured 2.85 million kilometers. These weren't comet tails, these were cosmic monuments, structures on a scale that dwarfed anything astronomers had documented from a comet before. And remember, this object had just survived its closest approach to the sun. It had been baked by temperatures that should have torn it apart. Most comets of similar size and composition would have fragmented into pieces during such an intense perihelion passage. The thermal stress alone should have cracked the nucleus. The violent outgassing should have blown it to rubble. Yet 3I Atlas came through intact. Not only intact, but actively creating these enormous tail structures that suggested it was venting material at rates that should have been catastrophic. The Virtual Telescope project, run by Gianluca Masi, captured images showing what he described as a much more developed ion tail with sharply defined luminous structure. The ion tail is the part of a comet's tail made of charged gas particles, and it was showing clear signs of increased activity. The comet was venting dust and gas more vigorously despite having already passed the point of maximum solar heating. This didn't make sense. Comets usually calm down after perihelion as they move away from the sun and temperatures drop, but 3I Atlas seemed to be ramping up. Even more puzzling was what scientists didn't observe: fragmentation. There was no evidence that the nucleus had broken apart. For an object undergoing such violent outgassing, creating tail structures millions of kilometers long, experiencing thermal stress that should crack it like an egg, the nucleus remained stable, intact, solid. Researchers started revising their estimates of its size upward. To survive this kind of abuse, the nucleus had to be much larger and more massive than anyone initially thought. Current estimates suggested somewhere between 5 to 10 kilometers in diameter, and its total mass, somewhere in the neighborhood of 50 billion tons or more. That's roughly 1 million times more massive than Oumuamua, thousands of times more massive than Borisov. This wasn't just another interstellar visitor. This was a giant among them. And somehow, despite losing an estimated 50 billion tons of material per month near perihelion, it held together. But there's one more piece to this emergence that nobody expected. On November 6th, the Meerkat radio telescope array in South Africa picked up something that had never been detected from an interstellar object before: radio signals. Specifically, emissions at specific wavelengths associated with hydroxyl radicals, these OH molecules that form when sunlight breaks apart water molecules in a comet's coma. When news of radio signals from 3I Atlas first leaked, the internet exploded. Radio signals from an interstellar object? Conspiracy theorists had a field day. Some claimed these were artificial transmissions. Others said it proved the object was an alien probe communicating with something. The speculation got completely out of hand. But here's what was actually happening, and it's arguably more fascinating than any conspiracy theory. Those radio emissions were completely natural. They were the signature of water sublimating from the comet's surface, getting hit by ultraviolet light from the sun and breaking down into hydroxyl radicals. These molecules emit at very specific radio frequencies, and Meerkat detected them for the first time because this was the first interstellar comet we'd been able to study with radio telescopes sensitive enough to see them. NASA researchers described it as powerful water jets erupting from the comet, comparing the outburst to a fire hose turned on full blast. This detection was actually groundbreaking for a completely different reason. Remember how the James Webb data showed this object was dominated by carbon dioxide, that unusual 8-to-1 ratio of CO2 to water? Well, these radio observations confirmed that despite the CO2 dominance, 3I Atlas still contains substantial water ice. The water content is low, only about 4% by volume, while CO2 makes up about 87% and carbon monoxide another 9%. But it's there, and it's actively sublimating, creating those hydroxyl emissions. So what actually emerged behind 3I Atlas after perihelion? Not alien technology, not evidence of extraterrestrial engineering. What emerged was something arguably more profound: evidence of natural physics operating at extremes we'd never witnessed before. A comet with a chemical composition unlike anything in our solar system, displaying structural integrity that defies our models, creating tail structures on a scale that rewrites the textbooks, all while carrying in its ancient ice the chemical fingerprints of a star system that existed billions of years before our sun was born. Making sense of the impossible. But here's where the story gets really interesting, because once astronomers had all this data, once they'd measured the impossible tail lengths and confirmed the bizarre composition and documented the survival of the nucleus, they had to answer a simple question. How? How does all of this happen naturally? How do you explain anti-tail jets and million-kilometer structures and a comet that refuses to die? The answer lies in something scientists are calling the radiation-cooked shell hypothesis, and it's beautiful in its elegance. Think about 3I Atlas's journey. For billions of years, possibly longer than our entire solar system has existed, this object has been drifting through interstellar space. During that time, it's been exposed to cosmic radiation, high-energy particles from exploding stars, from the galactic core, from every violent event in our corner of the Milky Way. It's been bombarded by ultraviolet light from distant stars. And all of this radiation has been slowly, methodically cooking the outer layers of the comet. Over billions of years, this radiation processing transformed the surface. Water ice got converted into carbon dioxide through chemical reactions driven by high-energy particles. Metal compounds got concentrated and altered, creating that strange nickel without iron signature. The very structure of the surface material changed, creating the bizarre polarization properties that made it unlike any object we'd seen before. The comet essentially developed a shell, a processed, radiation-baked outer layer that's fundamentally different from the pristine cometary material underneath. When 3I Atlas approached the sun, this shell started to sublimate, and because it was so heavily dominated by carbon dioxide, the sublimation was violent and created those initial anti-tail structures. As the comet got closer and temperatures increased, the sublimation rate went crazy. That processed outer layer, billions of years in the making, started blasting off into space. This explains the dual anti-tail jets. This explains the enormous tail structures. This explains the massive loss of material. It wasn't the whole comet disintegrating, it was just the shell, the processed outer layer, venting away. And here's the kicker. Beneath that shell lies more typical cometary material. That's where the water ice is. That's where the hydroxyl emissions are coming from. The nucleus survived because the shell, despite being violently ejected, was actually quite thin, maybe only a few meters deep. The bulk of the comet underneath is largely pristine material that's been protected for billions of years, shielded from radiation by that very shell that's now being blasted away. This model explains everything. The unusual composition? That's the processed shell. The survival of the nucleus. The shell was thin enough that losing it didn't destroy the comet. The massive tail structures? That's billions of years of radiation processing being ejected all at once. The anti-tail phenomenon? That's the unique way CO2-dominated sublimation behaves compared to water-dominated sublimation. Researchers Eric Keto and Avi Loeb, among others, worked out the math on this. They showed how carbon dioxide sublimation creates ice fragments that scatter sunlight in a way that produces those sunward-pointing anti-tail illusions. As temperatures increased, the sublimation shifted to creating normal dust-driven tails pushed back by solar wind. Post-perihelion, as the comet receded but still maintained elevated surface temperatures, both phenomena were visible simultaneously. That's why we saw both massive anti-tail jets and a conventional tail stretching millions of kilometers in the opposite direction. It wasn't artificial behavior, it was natural physics operating in a regime we'd simply never observed before. But even with this elegant explanation, mysteries remain. Why is 3I Atlas so massive? If interstellar objects are ejected from planetary systems through gravitational interactions with planets, you'd expect to see way more small objects than large ones. Statistically, little asteroids and tiny comets should be far more common than multi-kilometer behemoths. Yet here we have this giant, and we've only detected 3 interstellar visitors total. That statistical distribution doesn't make sense. Either we're missing thousands of smaller objects because they're too faint to detect, or there's something fundamentally wrong with our understanding of how interstellar objects are distributed in space. And what about that orbital alignment? 3I Atlas entered our solar system on a retrograde orbit, meaning it's moving opposite to the direction planets orbit. But here's the weird part. Despite being retrograde, its orbital plane is tilted only about 5 degrees from the ecliptic. The ecliptic is the plane where Earth and the other planets orbit. For an object coming from interstellar space, arriving from a random direction, to align so closely with our solar system's planetary plane is statistically unlikely. Researchers calculated the probability at about 0.2%. Now, is that proof of anything artificial? No. In an infinite universe, unlikely things happen all the time. But it's geometrically peculiar and worth noting. The extreme nickel composition also remains mysterious. As the comet approached the Sun, spectroscopic observations showed nickel and cyanide compositions rising sharply, indicating these elements were vaporizing at specific temperature thresholds. This suggests they exist in specific mineral phases in the comet's composition, phases that only form under particular conditions. What stellar environment creates those conditions? What kind of protoplanetary disk produces a comet with this exact chemical fingerprint? We don't know. We've never seen it before. Then there's the rapid rotation. Pre-perihelion observations revealed 3I Atlas was spinning with a period of about 16 hours. That's quite fast for such a massive object. Rapid rotation combined with violent outgassing creates complex dynamics. The centrifugal force from spinning enhances the outgassing on the sunlit side. This can create asymmetric jet patterns and contribute to those bizarre multi-jet structures we observed. But here's the question. How did such a massive object acquire this rapid rotation? Did it form spinning this fast billions of years ago? Or did something in interstellar space speed it up? Collisions are extremely rare in the void between stars, but not impossible. Or maybe the rotation is itself a clue to the formation environment, suggesting this comet formed in a high-velocity, turbulent region of its parent star system. What this means for us? The passage of 3I Atlas through our solar system represents more than just an astronomical curiosity. It's a window into the diversity of planetary systems across our galaxy. Every stellar system is slightly different. Different masses of stars, different metallicities, different planetary configurations, different radiation environments. And all of these differences leave chemical fingerprints in the objects that form there. By studying interstellar visitors like 3I Atlas, we're essentially doing galactic archaeology. We're sampling material from other star systems without having to travel light years to get there. Each interstellar object that passes through tells us something new about the conditions that exist elsewhere in the Milky Way. The high carbon dioxide to water ratio in 3I Atlas tells us that some stellar systems have protoplanetary disks where CO2 ice dominates the outer regions in ways that don't happen around stars like our Sun. The nickel enrichment suggests chemical processes or stellar compositions that differ from our local neighborhood. This matters because understanding the diversity of planetary system chemistry helps us understand how common or rare Earth-like environments might be. If every star system produces radically different cometary compositions, then the building blocks of planets vary wildly across the galaxy. That has implications for where we should look for life, what kinds of chemical signatures we should expect from exoplanets, and how the process of planet formation varies with stellar properties. 3I Atlas also demonstrated sublimation physics at extremes we'd never witnessed. The sheer scale of the tail structures, the violence of the outgassing, the survival of the nucleus through conditions that should have destroyed it, all of this pushes our models into new territory. We thought we understood cometary behavior pretty well. We've studied hundreds of comets in our own solar system. But 3I Atlas showed us that when you take cometary physics and apply it to an object with a billions of years processed surface, with an unusual composition, with a massive nucleus, you get phenomena that our existing models didn't predict. This is how science advances, not by confirming what we already know, but by finding the edge cases, the outliers, the objects that don't fit the categories. Those are the ones that force us to expand our understanding. And then there's the space weathering angle.
The radiation-cooked shell model provides direct observational evidence for what happens to icy objects over billions of years in interstellar space. Before 3I Atlas, we could only theorize about these processes. We knew cosmic rays and ultraviolet radiation would affect surfaces. We could calculate what should happen chemically, but we'd never actually seen the result. Now we have, and the result is weirder and more dramatic than many researchers expected. The surface of 3I Atlas underwent such profound transformation over its lifetime that it became compositionally distinct from the material beneath. That has implications for understanding our own Oort cloud objects, those distant icy bodies at the edge of our solar system that have spent billions of years exposed to cosmic radiation as well. So let's come back to where we started. Something massive emerged behind 3I Atlas. Not a hidden companion object, not an alien spacecraft, not a dark matter anomaly. What emerged was something arguably more extraordinary. Evidence of the universe's capacity to produce natural phenomena that transcend our expectations and challenge our assumptions. The massive jets stretching millions of kilometers through space. The impossible survival of a nucleus that should have shattered. The chemical composition that reads like a recipe from an alien cookbook. The radiation-processed shell telling a story of billions of years drifting through the void. All of this is real. All of it is natural. And all of it is a reminder that the cosmos operates on scales and timescales that dwarf human experience. This ancient traveler, possibly older than our entire solar system, carried in its ice and rock the fingerprints of a star system that might not even exist anymore. It survived a journey through interstellar space that lasted longer than multicellular life has existed on Earth. It endured billions of years of radiation bombardment that transformed its surface into something we'd never seen before. And when it finally made its closest approach to our sun, it put on a display of sublimation physics so violent and so beautiful that it forced us to rewrite our understanding of what comets can do. The truth about 3I Atlas is stranger than fiction because it doesn't need embellishment. The reality of an ancient, massive, compositionally bizarre interstellar comet creating million-kilometer tail structures while refusing to disintegrate is inherently more fascinating than any speculative alternative. It's a testament to the universe's creativity, to the fact that ordinary physics, when operating in extraordinary contexts over extraordinary timescales, produces genuinely awe-inspiring results. And here's what really keeps me up at night. 3I Atlas is only the third interstellar object we've ever detected. 3 in all of human history. Which means the universe is full of these travelers, full of objects carrying stories from distant star systems, from ancient epochs, from corners of the galaxy we'll never visit. And we've barely scratched the surface of understanding them. What will the fourth one show us? Or the 10th? Or the 100th? Each visitor is unique because each one formed in a different place, under different conditions, carrying different chemical memories. Every interstellar object that passes through is a message in a bottle from deep space and deep time, and we're only just now learning how to read them. The massive emergence behind 3I Atlas wasn't what anyone expected. It was better. It was weirder. It was more scientifically profound than the speculation that surrounded it. Because what actually emerged was a glimpse of how diverse and strange the universe really is. A reminder that nature, given enough time and enough space, will always find ways to surprise us. And that the true mysteries of the cosmos aren't violations of physics or evidence of alien engineering. They're the extraordinary things that happen when ordinary physics operates in context we've never encountered before. That's the real story of 3I Atlas. Not a mystery that needs an extraordinary explanation, but proof that the natural universe is more extraordinary than we ever imagined. If this blew your mind, you need to see what happened when scientists pointed every telescope at an object that changed velocity for no reason.